Have you ever wondered what would happen if the moon just vanished? One moment, our familiar celestial companion hanging like a silver sentinel in the velvet darkness. The next, nothing. An empty space where it once shone. It's a thought that borders on science fiction, a cosmic sleight of hand. But what if this unimaginable event became our reality? The consequences, my friends, would ripple through every facet of life on Earth, transforming our world into something alien, something profoundly different, and perhaps something terrifyingly hostile. My name is Abdullah Mohsin, and today we embark on a journey of cosmic speculation, grounded in the very real science that governs our planet and its faithful satellite. We'll explore the cascading chaos that would ensue if our moon were to be plucked from orbit. It's more than just losing our nighttime lamplight. It's about unraveling the intricate celestial mechanics that have shaped Earth into the haven for life that it is. Prepare yourselves as we peer into the abyss of a moonless Earth, a world teetering on the brink of catastrophic change. The silent silvery orb that has inspired poets, guided navigators, and governed the rhythms of life for eons, holds a power far greater than its serene appearance suggests. Its absence would trigger a domino effect, a symphony of destruction played out on a planetary scale. From the oceans that cradle life to the very spin of our planet, from the delicate dance of seasons to the primal instincts of creatures great and small, all would be thrown into disarray. So, buckle up as we explore what happens when the cosmic anchor is cut. The most immediate and visually spectacular consequence of the moon's disappearance would be the utter transformation of our planet's tides. For millennia, the moon's gravitational embrace has choreographed a delicate ballet with Earth's oceans, pulling them towards itself, creating the predictable ebb and flow we call high and low tides. This lunar influence accounts for about 2/3 of our tidal forces. The sun contributes the other third. Without the moon, this primary dance partner is gone. The sun's influence would remain, creating much weaker biannual solar tides, but the familiar twice-daily rhythm would cease. The seas wouldn't just become calmer, they'd become dangerously unpredictable. Imagine coastal cities, built painstakingly over centuries, suddenly facing a new, erratic tidal regime. The mean sea level itself wouldn't drastically change worldwide, but the patterns would. The much weaker solar tides would still cause some water movement, but the energy dissipated by the lunar tides, which acts as a brake on Earth's rotation and a stirrer of ocean currents, would vanish. Coastal ecosystems, those vibrant nurseries of marine life like mangrove forests and salt marshes, are exquisitely adapted to the moon-driven tidal cycles. They rely on the regular inundation and exposure. Without it, these vital habitats would face an existential crisis, unable to cope with the new, diminished, and less frequent water movements, leading to widespread collapse and a devastating loss of biodiversity. The intricate web of life in intertidal zones, from the smallest crustaceans to the birds that feed on them, would unravel. Species that time their reproduction or feeding to specific tidal states would find their ancient cues gone, their life cycles thrown into chaos. Furthermore, the mixing of ocean waters, driven in part by tidal flows, plays a crucial role in distributing heat and nutrients around the globe. While ocean currents driven by wind and temperature differences would persist, the loss of tidal mixing could alter these patterns in unforeseen ways, potentially impacting global climate and marine productivity on a scale we can barely comprehend. The oceans, the cradle of life, would become a far more hostile and unstable environment. Beyond the dramatic reshaping of our coastlines, the moon's absence would subtly yet profoundly alter the very length of our day. Think of the Earth-Moon system as a cosmic dance, a gravitational embrace that has been slowing Earth's rotation for billions of years. The tides raised by the moon on Earth act like a brake, gradually transferring angular momentum from Earth's spin to the moon's orbit, causing the moon to slowly recede from us and our days to lengthen. Without the moon, this primary braking mechanism is gone. The sun also exerts a tidal braking force, but it's significantly weaker. The immediate effect wouldn't be a sudden jarring shift, but over geological timescales the consequences would be significant. Initially, the change would be imperceptible to human senses, but century by century, millennium by millennium, the Earth would begin to spin faster. Our days, currently a comfortable 24 hours, would gradually shorten. This isn't science fiction, it's a direct consequence of the laws of physics, specifically the conservation of angular momentum. While the sun's much weaker tidal forces would still exert a minuscule braking effect, the dominant lunar brake would be gone. This means the energy that was once transferred to the moon to push it farther away would remain with Earth, manifesting as a quicker rotation. Life on Earth, including our own biological rhythms, has evolved in sync with a 24-hour cycle. A significant change, even over eons, would present an enormous evolutionary challenge. Consider the implications. A day might eventually shorten to perhaps 20 hours, then 15 or even less, though this would take many millions of years. This would mean more rapid transitions between sunlight and darkness, higher wind speeds due to a greater Coriolis effect, and a fundamental alteration to weather patterns. The carefully tuned circadian rhythms of plants and animals, including our own sleep-wake cycles, would be thrown into disarray. The very definition of a day would need constant revision. Our calendars, our clocks, our entire understanding of time as it relates to our planetary motion would be in flux. The silent, steady moon is, in essence, our planet's timekeeper, and its absence would send our terrestrial clock unwinding. The moon does more than just govern our tides and moderate our planet's spin. It acts as a vital stabilizer for Earth's axial tilt, the very reason we have predictable seasons. Our planet is tilted on its axis by roughly 23.5 degrees relative to its orbital plane around the Sun. This tilt is what gives us summer, autumn, winter, and spring. Without the moon's substantial gravitational influence, this axial tilt, also known as obliquity, would become far more unstable over geological time. Think of Earth as a spinning top. The moon's gravity acts like a gentle, steadying hand, preventing that top from wobbling too wildly. If the moon were to vanish, Earth's axial tilt could, over millions of years, vary dramatically, perhaps from nearly 0 degrees resulting in no seasons at all, just a monotonous global climate differentiated largely by latitude, to extreme tilts, possibly exceeding 45 degrees or more. Imagine a world where the poles receive direct overhead sunlight for extended periods, while equatorial regions experience prolonged, frigid darkness. Such drastic shifts would wreak havoc on global climate patterns. Ice ages could become far more severe and unpredictable, alternating with periods of extreme global heat. The relatively stable climate bands we know today, from tropical to temperate to polar, could shift, merge, or disappear entirely. The consequences for life would be catastrophic. Ecosystems have evolved over eons to thrive within specific seasonal patterns. If these patterns become erratic, with summers becoming lethally hot and winters unimaginably cold, or if seasons vanish altogether, mass extinctions would be inevitable. The delicate balance that allows agriculture to flourish, feeding billions, would be shattered. While these changes wouldn't happen overnight, the long-term trajectory for Earth would be one of increasing climatic instability and unpredictability. Our moon, in its silent vigil, shields us from a level of celestial chaos that would render Earth almost unrecognizable, a far less hospitable place for complex life to endure. Chapter 4. Whispers in the dark nature's disrupted rhythms. The moon is not just a rock in the sky, it's a beacon, a timekeeper, and a crucial environmental cue for countless species across the globe. Its gentle silvery light and the regular cycle of its phases have been woven into the fabric of animal behavior for hundreds of millions of years. If the moon were to vanish, the night would fall into an almost absolute darkness, save for the distant starlight. For nocturnal animals, this would be a profound shock. Predators that rely on moonlight to spot prey, like owls or certain big cats, would find hunting significantly more challenging. Conversely, prey animals that use the darkness of a new moon to hide might initially thrive, but the entire predator-prey dynamic would be upended. Consider the sea turtles, ancient mariners who navigate vast oceans and return to specific beaches to lay their eggs. Moonlight reflecting off the water often guides hatchlings to the sea. Without this beacon, countless young turtles might become disoriented, heading inland towards artificial lights or simply perishing on the sand. Many marine organisms, from corals to zooplankton, synchronize their spawning events with lunar cycles, releasing their eggs and sperm en masse to maximize fertilization. The disappearance of the moon would erase these ancient cues, potentially leading to reproductive failure on a massive scale, with devastating impacts throughout marine food webs. Even insects, many of which navigate by polarized moonlight, would find their nocturnal journeys thrown into chaos. The monthly rhythm of the moon also influences animal behavior in ways we are still discovering. From the foraging patterns of bats to the reproductive cycles of certain fish and mammals, the lunar clock is deeply embedded. Wolves, often mythically associated with howling at the moon, actually tend to hunt less during bright full moons, as prey are more vigilant. A perpetually dark night, save for starlight, would alter these hunting strategies. Migratory birds, some of which use the moon for navigation during their incredible journeys, would lose a crucial celestial guide. The intricate, often subtle dance between life on Earth and the lunar cycle would be broken, leading to widespread ecological disruption, stress on animal populations, and a quieter, more disoriented natural world. Chapter 5. The Empty Canvas, a Sky Without Its Muse. Imagine stepping outside on a clear night. You look up, expecting to see that familiar, comforting glow of the moon, perhaps a slender crescent, a radiant half, or a majestic full disk. But instead, there's only an unnerving profound blackness in its place. Without the moon, our night skies would become dramatically darker. The pervasive glow of moonlight, which often washes out fainter stars, would be gone. The Milky Way, our own galaxy, would blaze across the heavens with an intensity few modern city dwellers have ever witnessed. Countless more stars, nebulae, and distant galaxies would become visible to the naked eye, a truly breathtaking spectacle for astronomers and stargazers alike. This enhanced clarity would be a boon for astronomical observation, at least initially. Ground-based telescopes would peer deeper into the cosmos, unhindered by lunar light pollution. However, this darker sky would come at a profound psychological and cultural cost. For millennia, the moon has been a constant in human experience, a source of wonder, a subject of myth, poetry and art, a tool for timekeeping, and a beacon for navigation. Its absence would leave an undeniable void, not just in the sky, but in our collective human psyche. The rhythm of lunar phases, marking the passage of months, has been fundamental to calendars and cultural traditions across civilizations. This celestial metronome would fall silent. The very character of night would change. The soft, ethereal light that bathes landscapes on a moonlit night, creating shadows and mystery, would be replaced by a starker, deeper darkness. While the stars would offer their own cold, distant beauty, the familiar comfort of our nearest celestial neighbor would be gone. That gentle, reflected sunlight, which has illuminated lovers' walks, guided nocturnal travelers, and inspired countless dreams, would be an echo in our memory. The night sky, while revealing more of the universe's distant wonders, would feel profoundly empty, a constant reminder of our cosmic loss, a canvas missing its most prominent and cherished muse. Chapter 6. Echoes of Luna Humanity's Quest for Stability. So we've explored the cascading calamities, raging tides, a destabilized rotation, climatic chaos, disrupted ecosystems, and an eerily empty night sky. The question then becomes starkly clear. Could humanity, could life as we know it, survive in such a radically altered world? The immediate impacts on coastal regions would be devastating, displacing hundreds of millions and destroying vast swaths of infrastructure and fertile land. The long-term changes to Earth's rotation and axial tilt, while unfolding over millennia, would inexorably steer our planet towards a state of extreme environmental instability, making it increasingly difficult for complex societies and indeed complex life to persist. Human ingenuity is remarkable, and undoubtedly we would attempt to adapt. Perhaps we'd build colossal sea defenses, relocate entire populations inland, or develop new agricultural techniques for wildly unpredictable seasons. But the scale of the challenge would be unlike anything ever faced. The very predictability of our environment, which the moon helps guarantee, is a cornerstone of civilization. Could we then take the audacious step of trying to replace what was lost? Could we engineer an artificial moon? The sheer scale of such an undertaking is difficult to even comprehend. The moon's mass is over 81 times less than Earth's, but that's still an astronomical 73 quintillion metric tons. Creating an artificial object of sufficient mass and placing it in the correct orbit to replicate the moon's gravitational effects, its tidal influence, its stabilizing pull on our axis, would require resources and technological capabilities far beyond anything we currently possess. It would be a project dwarfing all previous human endeavors combined, requiring the mining of asteroids or other celestial bodies on an unimaginable scale. And even if we could construct such a behemoth, Could we ensure its long-term stability and perfectly replicate the delicate gravitational dance that nature perfected over billions of years? The prospect highlights just how precious and perhaps irreplaceable our natural satellite truly is. The silent, steady moon is not merely an ornament in our sky, it is a fundamental architect of Earth's habitability. The moon may seem small from here, a distant silent orb hanging in the vastness of space. Yet as we've journeyed through this thought experiment, its profound importance to life on Earth becomes undeniably clear. It is our cosmic partner, a gravitational anchor, a stabilizer of worlds, and a silent guardian that has shaped our planet's environment, its rhythms, and the very evolution of life that calls Earth home. Without it, Earth would be a completely different world, a more chaotic, unpredictable, and ultimately, a far more hostile place. From the gentle pull that stirs our oceans and slows our planet's spin, to the steadying hand that keeps our seasons in reliable succession, the moon's influence is woven into the very fabric of our existence. It reminds us that we are part of a larger cosmic system, where even seemingly remote celestial bodies can have a direct and vital impact on our daily lives. The delicate balance it helps maintain is a testament to the intricate interconnectedness of the universe, a balance that allowed life to take hold and flourish on this blue marble. Its absence would not only rewrite our planet's future, but also erase a profound part of our shared human heritage. The moon challenges us to look up, to wonder, and to appreciate the celestial mechanics that make our world possible. So the next time you gaze upon its silvery face, take a moment to consider its silent, tireless work. What do you think we'd miss the most if the moon disappeared? Share your thoughts in the comments below, and thank you for joining me on this cosmic exploration.